Dinesh. I am CTO at Civo, and we've got Alejandro here as well. And today we're talking about Open Control Plane, which is a new project that we have launched open source about a month ago. And it's about managing infrastructure slightly differently. So I'm CTO. I've been working in cloud for about 15 years now. I'm really interested in building technologies that scale, and building stuff in a public cloud or for a public cloud or as a public cloud is really kind of what scale is all about these days. So for those of you that don't know who Civo are or what we do, we are a public cloud provider. So we're sending hardware to various data centers around the world and then offering you the ability to launch Kubernetes clusters, machine learning workload, and object storage, all of these services that you're consuming from the cloud, but with us. And our real focus is on developer experience. So rather than you going through steps and steps and steps to get some very small infrastructure up and having to wait 20, 30 minutes for it to come online, we're really focused on giving you what you need to start playing around with the technologies that you're hearing about today in 90 seconds or less. Alejandro, do you want to give a quick intro?
My name is Alejandro. I'm working in Civo in the research team as Golang developer. This is my second talk in English, so be patient.
You're doing great, don't worry. So I think just want to go over what technology looks like today when we're deploying cloud infrastructure. So by a quick show of hands, has anyone used something like Terraform or Crossplane or even CLI tools to provision infrastructure? And have you had the experience of you move to a different cloud provider and everything is different? And the promise that Terraform had of you can just lift and shift your specs to cloud provider A or cloud provider B, has it worked for anyone? Hands up? No. So we all know that it's always different every time, and you have to relearn all of the tools that you're doing. One of the other problems that we're seeing as well is that things like Crossplane, you have to have a control cluster online that you install Crossplane onto. I'm not picking Crossplane for any particular reason. It's just one of the tools that do this. You have to provision a cluster, deploy some applications to it to then manage other infrastructure. And you're now in a position where you've got an unmanaged cluster living around that's actually key to everything that you're doing. And that's kind of a problem. So when we started looking at what was out there to solve these problems, there wasn't anything. And that's why we've got a new project called Open Control Plane. So Open Control Plane is trying to solve these problems by using kubectl itself to actually provision infrastructure. So if you're in Kubernetes or you're using Kubernetes, you're likely using something like kubectl or an equivalent like K9s or one of these other graphical tools day in and day out to create infrastructure or create pods. So our Open Control Plane project, is an open source project trying to get kubectl applied to any cloud provider. And we do that by having an API that is hosted with the cloud provider that you then talk to provision infrastructure. We've got a logo. We've also got a GitHub page. And we announced this a month ago. We're really looking for feedback from the community about what everyone thinks and how it works and how we should take the product forward. So I'd be really interested to have a conversation with you after you've seen this. There's an architecture little piece that Alejandro is going to do and a demo as well, assuming we can make technology work. So good luck, Alejandro.
Thank you. We built the Open Control Plane born in a conversation that we have one day in the research channel. What happens if you can create infrastructure using kubectl? So we think, okay, that's possible. And then we build a demo, work in progress project. And then we create OpenCP shim and the provider implementation. So the shim is like a project who contain interface who return the provider infrastructure in the way the kubectl can understand. So kubectl using custom resource returned by Kubernetes API in Open API format in protobuffer encode. So we built that from scratch, and we added new object to kubectl. So if you use kubectl and talk with Open Control Plane, and you say API resource, the API will return every resource that we have in that cluster or in that service. Both projects are open source. You can collaborate it. Open Control Plane there are 3 projects to build the Open Control Plane. We have OpenCP spec, who contain the protobuffer and the API specification to build the shim and the provider implementation. The provider implementation will be in charge of the cloud, because the provider implementation talk with the cloud using the library to create resource or talking to the API cloud for the cloud. The benefit that we see for the end user is one tool to rule them all, like a lot of the RIN. We have a RIN. You can well-known interface. Everyone have a kubectl, and everyone knows Gemify by default. So when you install your machine, you install kubectl by default. I think that is the first tool that you added in your system. Everyone knows the command. Kubectl get, kubectl describe, delete, apply, create. It's already there. So you use it every day. Also, we provide a filter by namespace. It's like we keep the namespace as network, because in Civo you have network, like in AWS and Amazon, DigitalOcean, Scalway, Linode, everyone use network. So you can change between network and added resource to the network using the same command that you use every day, -n or -a uppercase A, and you have all the network. The benefit for the cloud provider is a lot. They don't need to keep multiple tools and library up to date. So right now, the cloud provider, in our case, we need to keep updated Terraform, Crossplane, Civo Go library for Go. What else? Ruby library, Node.js library, and so on. So every time we introduce a new change in our API, we need to update every resource that we have. With this, we only need to update the OpenCP implementation, because you already have the client, and the client will bring the change from the shim, who is compatible with kubectl. So if we added a new service, we only need to add it to the shim, and when you say kubectl API resource, you will get the resource already there. So you don't need to update the Terraform provider or the CLI or anything. Yeah, the demo.
I'll hold this.
Hold this way.
You'll need to switch to mirror mode.
Okay. Mirror there?
Yep. Make it bigger.
Plus. Everyone see? Yeah. I will put it on a small example. This is like, I will create a namespace calling OpenCP, and then I will create a cluster who run in the namespace with a pool with the version of Kubernetes, and the cluster type is K3s. We have 2 types of cluster. We're using Talos or K3s. In this case, I will use K3s. So you only need to say kubectl apply keep cluster. Hope this works. in this moment, kubectl is talking with the CHIM. The CHIM is talking with the Civo implementation, and the Civo implementation is talking with our API. And we convert all that and return it to the kubectl in the right format. In that way, he can understand that he create an object in like a CRD or custom resource inside a Kubernetes. He just ready to create a namespace. Hopefully, we'll see he create a cluster. And if we say get key cluster -a, I put in the name. Okay, I want to say, give me all the cluster in that region. Oh, that is interesting. The chain work, you can deploy the API per region. Right now, when you're using the provider of Terraform, you need to specify the region. In this case, you only need a kubeconfig who say, this endpoint is for London, this endpoint is for New York. So when you want to change the region, you only need to change the context in kubectl. That's simple. You don't need anything else. Everything else is implied by the CHIM. As you can see, the cluster is building 41 seconds ago. The public IP. You can see we have one pool, the public IP, the state, and the age of the cluster. We can say describe. Describe key cluster London -n OpenCP. Describe, it's fine, right?
Describe DES.
My bad.
E.
Describe. Hopefully, this will return a YAML file with the structure of the cluster. Yeah, and the kubeconfig included. But you can see you have a namespace, you have a name. We don't have level of annotation. You have the API version, the kind, the metadata, the creation timestamp, UID. So if you see this for the first time and you don't know what is behind, you will say, this is a Kubernetes cluster. Because the CHIM acts as a Kubernetes cluster, but he don't create resource. He create infrastructure using kubectl. I have more demo, but I don't know if you're interested in see it. Yeah. The other one is to create an instance with a firewall. We have a firewall object. So we have support for every object that we have right now in Civo. We have the firewall who contain ingress with rules and contain egress with rules. The firewall has a name, and the virtual machine has a name in the same namespace, and we say firewall, my firewall. It will be the same. You can say kubectl apply instance. Hopefully, it will create a firewall and an instance in the same network. I hate the notification. He already created the firewall. He's waiting for the response from the CHIM saying, okay, the firewall is done, create the virtual machine. And now you can list it's already there. I know it. get the virtual machine in every namespace that you have. It should be in building state, the same. As you can see, I have OpenCP is here, is in building state. But if I say, give me only the virtual machine in the namespace OpenCP, he only will return 1. So kubectl add like kubectl. You can filter by namespace. I returning just 1. That's it.
Slides.
Oh, the slide. Oh, sorry. I need to change back to the.
So Alejandro is doing that. I think our goal with this project is that those specs that you saw, we're trying to make that portable between cloud providers so that you could take that same spec for a VM and a firewall, and the shim implementation would say that you're connected to something like DigitalOcean, and that shim would be responsible for taking that same spec and making now a DigitalOcean firewall and a DigitalOcean instance.
Yep.
So, yeah, I think obviously this is a very early release. We've only got a few resources supported today, but if you want to get involved, it's a fully open source project on GitHub. We're just looking for feedback. We're looking for users to start interacting with it and using it. As an example of how to use it with Civo, as Alejandro was saying, there is a kubeconfig is the main thing that you use. So here we've got the kubeconfig, pretty simple if you've seen this before. The cluster we're defining as the region that you're connecting to. The namespace is the network that your resources are in, or a VPC if you're used to that way of working. And then the token at the moment is just a bearer token, but with the work that's into Kubernetes, we can do things like OAuth tokens as well and build that all in. The initial release is just a easy to get it out there bearer token. So if you do want to get involved, we give away $250 free credit. So you can try that out today. That config is in the OpenCP documentation as well about how to get started. And yeah, you just pull out the API key.